Hello, everyone, and welcome back to If It's Math. Today, we're going to start our series on exponents as part of our Fundamentals of Algebra content. In this video, we'll talk about what exponents are and the differences between positive and negative exponents. So by the end of this video, you'll be able to use both positive and negative exponents to understand algebraic expressions. So let's go ahead and get started. So when we start thinking about exponents, you'll use them the rest of your time in algebra. And really, the goal, even though it gets really complicated, is actually to make things easier. So, exponents represent a shorthand way to write out repeat multiplication. So, if you always just keep that in mind, that anytime you're dealing with exponents, that's the point. They are repeated multiplication. So, you're doing the same thing over and over. So, if you think about something like 3 times 3, right? That's pretty easy to write out. That doesn't get confusing. So we know that 3 times 3 is 9. It's a really straightforward thing to calculate out. And if we have 3 times 3 times 3, okay, it's getting a little more complicated, but we can still work through it. So we have that first 3 times 3 is 9. Then we have one more times 3, which is going to give us our 27. So, okay, not too bad. But what if we had something like 3 times 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 3? Yeah, I don't want to have to write that again. So uh, what exponents do is they really give you a way to write this in an easier format. So what we know for exponents is if we have, for instance, 3 times 3, then that is the same as 3 raised to the second power, or 3 squared. So the same thing if you have x times x, that gives you x squared. So again, that exponent representing repeated multiplication. So if we have x times x times x times x, we've got 4 of them now. So that's x to the 4th power. So that's really all you do. If you're trying to figure out how to write it in exponent form, I'm multiplying x by itself 4 different times. So I put my base here as x. I count up the number of times. In this case, we have 4. And that's what goes into that exponent right there. So that creates that x to the 4th power. And this works with anything. So if we have y multiplied by itself a whole bunch of times, say that we had that. Again, you're going to take your base, because everything here is y's. It only works if everything's exactly the same. So we've got that base is going to be y. And then to figure out what the power is, I'm going to add it all up. So I've got 1, 2, 3, 4, 5, 6, 7 of them. So that tells me the exponent is going to be 7. So that's y to the 7th power. So that's what exponents are. It's just multiply whatever is in that base by itself, however many times is indicated in that exponent. So let's do a few examples just to be sure we've got this. So if you had 3 to the 4th power, we're going to undo it this time. So I know I'm going to multiply 3 by itself 4 times. So then you just kind of collapse it down. So the first 3 times 3 is going to give me 9. And I've still got 2 of them left. So that's going to give me 27 times 3. And then that is 81. So 3 to the 4th power equals 81. That's how you'd read that. 3 to the 4th power equals 81. So then if we had x to the 3rd power, remember you're just going to take x and multiply it by itself 3 times. So one I do want to talk about really quickly, just to be sure you know, x to the 1st power is x not multiplied by itself any times. So that's x. So anything raised to the first power is just itself. Okay, so those were some straightforward examples. Let's look at some ones that are a little bit more tricky. So let's say you have minus 3 to the fourth power. So with exponents, you have to really, really pay attention to what is being covered by that exponent. So this is negative 3 to the fourth power. It's not negative 3 to the fourth power. So that is going to give you negative 3 times 3 times 3 times 3. So you'll have negative 9 again times 3 times 3, which will give you negative 27 times 3, which will give you negative 81. So negative 3 to the fourth power is negative 81. So again, really pay attention to where those exponents are. So what if it had been negative 3 to the fourth power? So let's actually do that this time. So the difference here you'll see is my negative's not on the outside, it's inside that exponent. So this is going to be negative 3 times negative 3 times negative 3 times negative 3. So my negative 3 times negative 3 is going to give me positive 7, positive 9, still times a negative 3 times a negative 3. So my 9 times negative 3 is going to give me a negative 27 times negative 3, which will give me a positive 81. So you can see that's why it's really important to pay attention to where those negative signs are. But it's not just negative signs, it's anything. So if you have 4x to the third, kind of like where the negative sign was. This 4 is not a part of the exponent. It's just the x. It's only whatever the exponent touches. So 4 times x to the third is 4 times x times x times x. You don't have that 4 inside of it. If you did, it would be 4x to the third. And in that case, you would have 4x times 4x times 4x times 4x. So that's the big difference there. So then if you needed to simplify this out, oh, I got an extra one there. 4 times x to the third, so just 3 of them. So then if you needed to simplify that out, remember you can use the correct properties here to put all the 4's together. Then the x's together. So this would give you 16 times 4, x, x, x. And 16 times 4 is going to give you that 64 times x times x times x, which then if you wanted to put it back in exponent form, 64x to the third. So you see what a big difference that makes. So what if you had minus y squared? Again, you've got to pay attention to where everything is. So this is just negative y times y. And if you had negative y squared, then that would give you negative y times negative y, which would be negative 1 times negative 1 times y, which would just give you y times y. Okay, so we've only looked at positive exponents so far. So let's look at our negative exponents. So what negative exponents represent is really the inverse of their positive counterpart. So, putting that in plain English, you just put 1 over everything affected by that exponent. So if you have 2 to the negative 1, that is 1/2. So if you have x to the negative 1, that is 1 over x. So let's do a few more comparisons. If you have 2 squared, that is 2 times 2, which is 4. But if you have 2 to the negative 2, that is the same as 1 over 2 squared, which is going to give you 1 over 2 times 2, which is 1/4. So that generalizes out, right? It doesn't just have to be numbers. It applies to variables as well. So if you have x squared, x times x to the negative 2 is 1 over x times x. So other than that, negative exponents are exactly the same as positive. It just means flip it over. That's really all that negative exponent tells you. So let's do a few more examples. If we had negative x to the negative 4th, again, pay close attention to whether or not that negative sign is in the exponent. It's not in this case because we don't have those parentheses there. So what this is going to give you is negative 1 over x times x times x times x. Because it would have been x, negative x to the positive 4th would have been negative x times x times x times x. Since it's a negative exponent, it's negative 1 over x times x times x times x. But what if it was inside? So negative x to the negative 4th power. So that's going to give you 1 over negative x, negative x, negative x, negative x. You can regroup all those negatives. So you have 1 over negative 1, negative 1, negative 1, negative 1. And then it's going to keep going. X, 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 x. These negative 1s are going to end up all canceling out, right? So you have negative 1 and negative 1 is positive. Negative 1 and negative 1 is positive. So the only thing that's left is your 1 over x times x times x times x. So that's really all there is to exponents. Just remember, the main point here is that they're a shorthand way for how many times to multiply something by itself. So you're repeating the same thing over and over. I did a lot of these examples, so you can probably understand why. I think this is important to keep track of what is covered by the exponent, because if you don't have the negative inside of it or the number inside of it, whatever it is, it's not the same thing. So 2x squared is very different from 2x squared because 2x raised to the second power is 4x squared, right? Because you had the 2 inside that exponent, whether or not you did. Then with negative exponents, remember it means to do the inverse or kind of flip it over. So you have y to the negative third. That is 1 over y to the third. And that's all there is to positive and negative exponents. I hope that was helpful. Please like this video if it was. Be sure to subscribe to our channel to be the first to know about new content. And always remember that if it's math, we have the solution.